Hey guys, we're in section 17. I want you to write the title. The title is Find the Perimeter, Circumference, and Area. And I'd also like you to write today's date. You know how it is. Let's get started. So our first word is perimeter. So the perimeter is the total distance around the sides of a polygon. For instance, if I were to find the measures of each side of this rectangle and add each of those up, and get the sum, that would be the perimeter. The same thing for this triangle and also this hexagon. So again, the perimeter is the sum of all the sides or the total distance around the sides of a polygon. Okay, so for instance, let's zoom in on this triangle and let's talk about what the circumference would be if this side is 9 centimeters and this is 7 centimeters and this is 4 centimeters. If we add up all of those sides, right, the length of 9 plus 7 plus 4, we get 20 centimeters. So the perimeter of this particular shape of this triangle would be 20 centimeters. Our next word is circumference, which is a lot like perimeter, except when we're talking about a circle. So circumference is kind of the perimeter of a circle. So the circumference is going to be referred to as the distance around a circle. So if you were to measure this distance all the way around, that would be the circumference of the circle. Our next word is area. So what area is, when we talk about area, what I want you to be thinking about is the idea that area is the amount of surface covered by a figure. So if we had the following figures, area is going to be the space kind of inside these shapes, the space inside or the surface area that's covered by the shape. And so when we measure area, we usually measure it by square inches or square feet or square centimeters, because we think of the area inside as almost like little tiny squares that we are using to cover that space or cover that surface. The word diameter specifically deals with circles, and it is the line drawn from one part of the circle to across to the other part, and it goes through the center of the circle. There's another name for this. It's called a chord. It's the chord of a circle that goes from one side through the center of the circle to the other side. So that's what a diameter is, and I'm going to highlight that and highlight the whole thing. So that's our diameter right there. So the diameter goes straight through the center and it touches the two edges of the circle. We have another word, radius, and what the radius is, it goes from the very center of the circle and it goes out to the edge. So a radius is honestly half of a diameter. Here's an example of a radius. It goes from the center of the circle right out to the edge, and you could see that the radius would be half of a diameter. And that's it for our vocabulary words, but we're going to have some definitions, well, some formulas that I want you to make sure and copy down. So again, a diameter is just a segment with endpoints on a circle that passes through the center of that circle, and a radius is just a segment with one endpoint at the center of the circle and the other one on the circle itself. All right, let's get into these formulas. All right, so we're going to be talking a little bit about area formulas and perimeter or circumference formulas for the next few shapes. So I want you to take a look at this. So our first shape is a square, and the length of the sides of the squares are all going to be the same. So I could say that this side is S and this side is S. If I wanted to find the area of a square, I would say that the area is equal to S times S, or S to the second power. The perimeter of a square, since all the sides are the same and we've got 4 of the same sides, it would be 4S. So that's what we have for a square. Let's take a look at a rectangle. So when we have a rectangle, we have the width and the length. And when we talk about that area, we're going to call the area the length times the width. In order to find the perimeter or the length of the outside, we're going to take 2 widths, because we've got 2 widths and 2 lengths, and we know that the perimeter is equal to 2 times the length plus 2 times the width. We've got 2 more shapes that we're going to take on. We're going to take on the triangle, and then we're going to take on the circle. When thinking of a triangle, we're going to talk about parts of the triangle that we might not have said before, but a triangle has a height and it has a base. And when you consider the height and the base of the triangle and you want to write the area of that, the area is going to be equal to 1/2 times the base times the height. That's how you find the area of a triangle. But if you wanted to find the perimeter of the triangle, you need to know the length of all the sides. So let's say we refer to this side as D, and we already said that this side was B and this side is F. So if I wanted to find the perimeter of this triangle, I'd have to add up the sum of all the sides, or the lengths of all the sides. So in this case, it would be F plus D plus B. So our final shape is the circle that we're going to discuss, and we're going to talk all about the circle in terms of its area. But before we do that, we need to mark off some important things. When we have a circle, we need to keep in mind that the radius, that's the measure from the center to the edge, is the main thing that we need to know about. So whatever this length is, this is how we're going to find first the area. The area of a circle is equal to pi. That's a whole number that we need to talk, not a whole number, that's actually a number that we're going to talk about, and times r, that's the radius, to the second power. So pi is the number 3.14, goes on forever and ever. So I'm going to use this symbol here to say it's about 3.14. Maybe back in the day you used the fraction 22/7. To represent an approximation of pi, but when you see this symbol, that's actually a number, and your calculator has a different approximation, better than both of these, but we can't ever have the exact value because it's an irrational number and it goes on forever and ever. So pi is going to be used here for the area, and we're also going to use pi for the perimeter, which we call the circumference when we're dealing with a circle. So that one's going to be 2 times pi, there's that number again, times the radius. So here's the circumference of a circle, and here's the area of a circle. So those are the only formulas that we're going to be working with for the most part in this section. Let's go ahead and turn our attention to some of the examples. So let's get down here. For example 1, we're going to find the perimeter and area of a rectangle. In this case, our rectangle is our basketball court. Find the perimeter and area of the rectangular basketball court shown. So the perimeter of a rectangle would be 2 times the length plus 2 times the width. We see that the length here is 84 feet and the width is 50. So we're going to just substitute in those values in order to find the perimeter. 2 times 84 plus 2 times 50. When I calculate 2 times 84, I get 168. When I calculate 2 times 50, I get 100. Therefore, the perimeter is equal to the sum of those two, which is 268. And now we need to consider the units. If we're talking about feet as the length and width, we need to add feet here for our final answer. The perimeter is 268 feet. Let's go ahead and find the area. Area is calculated when we're dealing with a rectangle as length times width. Because of that, we're now going to multiply. I'm going to get this out of the way. We're going to multiply 84 times 50. So 84 times 50 is going to give me an area of 4,200 feet squared. Why squared feet, or why feet squared? This is how I'd write that. Because when we're measuring area, we're measuring how much space is being covered, in this case by this basketball court. And so I'm measuring all the little square feet across and down. And if I were to count all of those square feet up, I'd get 4,200 square feet. In example 2, we're actually dealing with a circle. You are ordering a circular cloth patch for your soccer team's uniform. Find the approximate circumference and area of the patch shown. So we've got to find circumference and area. Let me first write down those two formulas. In both of the formulas that we have, circumference 2 times pi times r and area pi times r squared, in both of those we're going to be needing to have the radius. And we remember talking earlier, and maybe you don't remember this, but earlier in the video I talked about the fact that the diameter is really 2 times the radius. So one diameter is equal to 2 radii, 2 radiuses. if you will. We have the diameter here. Because the length of the patch is 9 centimeters, we know if we were to run a segment through the center of this circle, we would have 9 centimeters. That tells me that the radius has to be half of that. In this case, the radius must be 4.5 or 4.5 centimeters. We're going to use 4.5 for our calculations. So for the circumference, we know it's going to be 2 times pi times the radius. In this case, that's 4.5. If I'm going to write this answer in its exact value to the best of my ability, I'm going to leave pi in the problem, and I'm just going to deal with the numbers that are easy for me to calculate. 2 times 4.5 is 9. So this answer, exact answer, is 9 pi centimeters. I can calculate the approximate value of this by putting in the approximate value for pi, which is 3.14, but there's something I want you to see here. Did you notice that the diameter was 9, and when we finished, our circumference was 9 times pi? That also means that another definition or another formula for circumference could be pi times the diameter, because we could have just said 9 times pi, or 9 pi is the circumference of the circle. I hope you're walking with me. Now for that approximation. So when I put 3.14 as an approximate value for pi and I multiply that by 9, I get 28 and 26 hundredths of a centimeter. That's going to be my circumference. Let's talk about the area. Since we already found that the radius is 4.5, we're going to use that to find the area. Remember, area is pi times r squared. So I'm going to multiply pi times 4.5 to the second power. 4.5 to the second power is actually 20.25. So the final answer could be 20.25, and in this case, centimeters squared, 20.25 pi times centimeters squared. But we're going to do what we did last time. We're going to find the approximate value. So we're going to take the 20.25 and multiply that by 3.14, and we get 63.585 or 585 thousandths of the square centimeters that we're dealing with. So that's our circumference, and this is our approximate area. For this next example, we're given that triangle QRS has certain vertices. Q is at 1, 2, and then R is located at 4, 6, and then we have S, which is located at 5, 2. With that in mind, we are now going to try to figure out what the perimeter is. So a couple things we have to do. We've got to figure out the lengths of all of these sides. Now the cool thing is we've been practicing finding the lengths of segments. We can use the distance formula. So for this first one, I'm not going to use the distance formula. I want you to see that if this one is at 1, and then we go all the way over here to 5, we already know the length of this has to be 4. 5 minus 1 is 4. So QS is 4. So that's part of the job. Now we've got to find RS and QS, and we can use the distance formula for both of those. If you don't remember the distance formula, know that it's on the front cover of your notes packets. We're going to do the difference between the x terms squared plus the difference between the y term squared, then we're going to take the square root of it. So we're dealing with R and S, and I'm going to call this x sub 1, y sub 1, x sub 2, y sub 2. So this is 5 minus 4, and then 2 minus 6. We're going to take that and square it. We end up with the square root of 1 squared plus negative 4 squared, which is then going to lead us to the square root of 1 plus 16, which is the square root of 17. So that's our value for RS. Now we've got to find our value for, okay, we can also approximate this. We know this is going to be approximately 4 point something. If we go ahead and put it in our calculator, we're going to get approximately 4.1. So I'm going to leave that there. And now we're going to calculate the value for, we've got RS, we've got QS, we've got to get QR. So we're going to deal with QR next. Again, by applying the distance formula, we've got to find the difference between the x terms and the difference between the y terms. So I'm going to go with a 4 minus 1 and then a 6 minus 2. and those those differences are going to be squared. 4 minus 1 is 3. 3 squared is going to give me 9. 6 minus 2 is 4. 4 squared is going to give me 16. When I'm done with this, I'm actually going to end up with 9 plus 16, which is 25. So the square root of 25 is 5. So let's go ahead and get that circumference, not circumference, let's go ahead and get that perimeter. So we know that QR is 5. We know that RS is 4.1. When I add all of this up, 5 and 4 is 9. And 9 plus 4 is going to give me 13. So I get about 13.1 units, and we see that the answer is there. All right, let's do this final example. I like example 4, but we are going to skip it for right now for the sake of the length of the video, and we're going to go straight to example 5. So example 5 is our final example. The base of a triangle is 28 meters and its area is 308 square meters. Find the height of the triangle. Well, we're not finding the area, but they did give us information about the area. They also gave us information about the base, and we're looking for the height. So here's what you're going to do. You're going to write down the area of a triangle is equal to 1/2 the base times the height. I put the order differently, but it's not a big deal. 1/2 the base times the height. What you're going to do is put in the given information, and then we're going to figure out what we need to find. The first thing they said is that the base is 28. So I'm going to rewrite this formula with 28 in there for the base. The next thing I'm going to do is recognize that they also gave me the area, which is 308 square meters. So I'll rewrite the formula now with 308 added in there. Now that I've done that, I see that my only variable left is the one that we're looking for, which is the height. That's a good thing because I know how to solve this equation, and so do you. Here's what we'll do. We'll take a moment. We will isolate the variable. We're going to isolate h, but first we need to simplify what's going on. If I have 1/2 times 28, what I'm going to do is multiply those two, and I get 14h. So 308 is equal to 14h, and whenever I find myself in this situation, I know I just have to divide. I'm going to divide both sides by 14. When I do that, I get that that height is equal to 22, and since we're dealing with meters, it would be 22 meters. And honestly, that's it for this section, and that's also the end of this chapter. If your packet is still intact, you might have the chapter test here for you. This would be an excellent way to start to get ready for the tests for this entire chapter or unit. All right. I look forward to talking to you soon. We're going to have more time to prepare for the test, but definitely make sure you get all of this down. Take care, guys. Bye-bye.